So the today topic is block encoding. Block means here we will see 4B to 5B block encoding. So the block coding, here the block coding means MB here, M, B and NB. B is for the bit, right? So actually it gives the redundancy to ensure the synchronization and the error detection. You know the synchronization. So each and every bit should be synchronized with the signal. Then only the exact value will be received to the destination, right? And the error detection. If anything happen or the perfect data will not reach to the destination, means some of the error will be acquired. So we have to check the error. So both process will happen in the block coding technique. So the redundancy means the same data or bit repeated continuously. And next point here, changes block of M bit. Here changes the block of M bit into the block of N bit. Actually the N is larger than M. N should be larger than M. So what I am going to do here, the block encoding, I have some block or data and I am going to add another one block to encode the corresponding original data. That is called the block coding method. The M bit is into the block of N bits. Then the next one, it is distinguished from the multi-level coding by the use of slash, that is MB/NB. B is a bit, right? And also it is divided into three types. It is divided into three types. The first one here, division. The first method here, that is the division. So the division means here the sequence of bits is divided into groups. The corresponding sequence of bits. So what are the sequence of bits is that the actual data will be converted into sequence of bits, the stream of bits. That it is divided into several groups. That is called the M bit. That is called the M bit. And the substitution method means here the substitute M bit group for the N bit group. So I am going to map. I am going to map instead of that M bit to the N bit. So the substitute M bit, corresponding M bit group for the N bit group. That is the second method. And the third method, combination. So the combination is nothing but to combine the N bit group into the string. So I just mingle. For example, it is like the corresponding original bit is 101. I am going to add some other bit 100. So the final bit will come 01101, whatever it is. Some of the mixed of the corresponding original data as well as the encoding data or the encoding bit. So that is called the combination of. So why I want to combine or divide or substitution method for this? So it is generate the perfect encoding technique to secure the corresponding data. For example, here 4B/5B. So these are the types of block coding. Here 4B/5B, 8B/10B, or B8 is ZS, HDB3. So these are the stream of block coding methods. What happened? The corresponding 4-bit data is converted to 5-bit. 8-bit data is converted to 10-bit. So this is a separate encoding method, separate block coding method. So see here, this is a block coding concept. So the division of stream into M bit group, the corresponding division of stream into M bit stream. So this is the original data. The corresponding original data is converted into zeros and ones. So that is also divided into several groups. That is also divided into several groups. For example, 1001, 101. So M1, M2, M3, M4 till the entire message is converted into bit stream, and that bit stream is converted into group of M bits. That is the first step. So what the next step here? The M bits is combined or substitute with the NB. NB means that is some other bit, right? So instead of that original message of M bit, the group of M bit streams, is convert into the n-bit stream. That is a combining n-bit group stream into the stream. So the actual message is encoded now by using this combination method. The original message is combined or converted into the encoding format, right? So this is a block coding. Separate each block. I didn't synchronize or convert the individual bits. So the collection of bits going to encrypted simultaneously, right? So using the block coding here 4B/5B with NRZI line encoding. You know very well. Yeah, NRZI encoding. Here corresponding NRZI encoding method. So the NRZ, I think my voice is clear now, right? Okay, so here using the block of 4B and 5B with the NRZI means the line encoding, you know very well about NRZI, that is the inversion. That is a inversion. So the inversion method means when the next bit is 1, then only the corresponding bit, the code will be changed. Otherwise, it's continue. That is a concept of NRI. So NRZI. So I'm going to apply the NRZI encoding method into the 4B to 5B encoding. So it is a double encoded method to encrypt my data with effective or more secure, right? So this is a way to encrypt the data. This 4B and 5B is encoded here. The digital signal here, the corresponding digital signal or link will be reached to the destination. So this is a block of coding. So instead of the individual bit conversion, the block of bits will be converted into using this NRI and 4B 5B encoding method. It's a very simple concept only. Okay, now we have to see about the redundancy. That is nothing but a bit data word can have the 16 combination. 4-bit data word can have the 16-bit combination, and 5-bit data word have 32 is combination. So what I am going to implement by using this 4-bit and 5-bit, so therefore we have 32 minus 16, 16 extra words will be added. Here the corresponding 16 extra word will be added. So some of the extra word are used for control or the signaling purpose, and also it's a encrypted method. Here I can encrypt the corresponding method. Fine. So for example here see, so this is the original text, right? This is the original text. It is a example of 4-bit. Okay, 4-bit text is a 4-bit. Okay, so this is the original source message. I'm going to encrypt by using the NRZI method. Before that, I'm going to apply the 4B 5B conversion. So this is the original text is going to apply with 4B/5B method. So the 5B means the 5B value. Here the corresponding 5B value welcome. Some of the value is welcome. So what happened? The 5B, the corresponding 4B will be converted into 5B. The actual text will convert. So like this, the combination of the original text with the 5B method, 5B combination, here G. So here I, C and G. So this is a encoding. This is actual encoding. What happened? The original good morning message is added with the welcome text, that is a 5B concept text, and convert into the encoding type. Here it's convert into the encoding type. So this is a sender side. So what happened in the receiver side, the corresponding receiver side, the same, this is a encoding, right? So the decoding method, the corresponding original, the encoded message is deformed with the 5B value, that is a welcome value. It's split and convert into the original text. The corresponding original text here, good morning, will be displayed here in the receiver side. So this is a conversion. This is a corresponding conversion method. So this is a block coding. So what happened? It's a block. The corresponding good is a one block, morning is a one block. So it is a combination of welcome. So it's mixed of this block and this block. The corresponding encoded text will be ready and convert into the or sent into the destination. In the destination side, it will reverse process and get the original code. So instead of this good morning or welcome, I'm going to give the corresponding zeros and ones. So this is the original message. You just imagine this is the original message. Okay, so it's converted into 3 block, and this is a 5B value here. This is a 5B value, and the combination of this block and this block, it's generate the corresponding sum of the text here. Okay, the one extra bit will be added because it's added in the extra bit. So the original text is 4-bit, means here the actual text will be the 5-bit. It's convert into the 4-bit to 5-bit. That is a conversion. That is a conversion method, right? Here, see here, come to the PPT. So this is a combination extra. 16 extra words will be added based on the 4-bit and the 5-bit conversion method, because the combination of the 4-bit is a 16 and 5-bit means 32. So 32 minus 16, 16 extra word will be added for the encrypted purpose, right? This is called the redundancy method. So the substitution method in 4B and 5B block like this. Already I just explained now. So this is some block. So this block will add with another one. This is a n bit, and it's a m bit. It's a n bit. So in this 4B/5B, the 5-bit output that replace the 4-bit input as no more than one leading zero. No more than leading zero, and no more than the 2 trailing zeros. Here the right bits, if this is 2 trailing zeros, so when the different group are combined to make the new sequence, that there are never more than 3 consecutive zeros. So when I am going to convert the original 4-bit blocks to 5-bit block, it should not with consecutive zeros of 3. So this is a structure or the idea to convert the block code encoding, the 4-bit block to 5-bit block. Okay, so this is a conversion method. So the 4B and 5B mapping will be, it's a theory part only. So this is a 4 zeros and it's convert to 5 bit. So here the input is 4 bit, the output is 5 bit. So some extra bit will be added based on some conversion. So here the original data, this is a code for the 4 bit. This is a 1 2 3 4 4. So this is the input 4 bit value. This is a 5 bit value. So combination of this conversion, I can get the some new sequence to send the encoding text. So this is called the sum of the sequence, the data sequence, encoded sequence. Encoded sequence is added with some calculation. So the control sequence Q, I, H, these are the set of indicator to convert the method. So the encoded sequence will be like this. Here, this is a sequence of like this. So the last code will be added here. Okay, so some conversion will be happen to the combination of the data sequence and the encoded sequence. So this is called the block codes method based on the input, based on the 4B and 5B.